Differentiation, mixed exercise. The derivative of an algebraic term given in the form ax to the power of n is anx to the power of n minus 1. You may find it useful to remember this rule as multiply by the power and reduce the power by 1. Sometimes you might be asked to differentiate quite a complex equation, and it helps to remember these 3 steps. Number 1. Fully simplify the equation. This might include multiplying out any brackets and cancelling down fractions. Number 2. Use index laws to express each term in the form ax to the power of n. The rule for negative indices is used when you have a variable, for example x, on the denominator of a fraction. In this case, you can get rid of the fraction by giving the x a negative power instead. Some examples of this are 3 over x squared equals 3x to the power of minus 2, and 1 over 4t cubed equals a quarter t to the power of minus 3. The rule for fractions is used when you're dealing with roots. The root becomes the denominator of the fractional power. For example, the cube root of x can be written as x to the power of a third. The square root of p to the power of 5 can be written as p to the power of 5 over 2. And finally, step 3, differentiate each term in turn. Let's look at some examples. In this question, we have both a set of brackets and a fraction, so we need to simplify. Multiplying out the brackets on the numerator of the fraction gives us y equals 2x squared minus 7x minus 15 over x. Now we distribute the division by x to each term. And finally, cancel down each fraction. The first and second term of the equation are already written in the form ax to the power of n. However, we need to apply our index law to the third term before we can differentiate it. 15 over x can be written as 15x to the power of minus 1. Now that all of our terms are in the form ax to the power of n, we can differentiate each one in turn using our rule, multiply by the power and reduce by 1. So, 2x differentiates to 2, minus 7 is a constant term, so it disappears when we differentiate, and minus 15x to the power of minus 1 differentiates to 15x to the power of minus 2. Our answer is dy by dx equals 2 plus 15x to the power of minus 2. In this example, we will have to use index laws on both the second and third term of the equation to get them in the form ax to the power of n before we can differentiate. Try it yourself. Pause the video now and have a go. Let's look at the answer. 6 over x squared can be written in the form 6x to the power of minus 2, and the square root of x can be written as x to the power of a half. Now we can differentiate. 3x squared differentiates to 6x. 6x to the power of minus 2 differentiates to minus 12x to the power of minus 3, and x to the power of a half differentiates to a half x to the power of minus a half. Our answer is dy by dx equals 6x minus 12x to the power of minus 3 plus a half x to the power of minus a half. Well done if you got it correct.